2. Welcome to example number 3 of this chapter. So, we are continuing with speed and velocity, trying to differentiate that whilst also drawing the speed versus time graphs and also the velocity versus time graphs. So, in this example, we are told of a train. In fact, let me read it out loud in case you can't read my writing. Unfortunately, I'm gonna butcher some of these spellings, pronunciations of these circuses. On the London Underground, Oxford Circus and Piccadilly Circus are 0.8 kilometers apart. A train accelerates uniformly to a maximum speed when leaving Oxford, Circus and maintains the speed for 9 seconds before decelerating uniformly to stop at Piccadilly Circus. The whole journey takes 2 minutes. Find the maximum speed. So the train is accelerating, it reaches a maximum speed, and it maintains the speed for 9 seconds before it slows down and comes to a stop at another circle. So those are our keywords. And fortunately for us, this train is traveling uniformly. That's very important. You see uniformly there, and another before decelerating uniformly to a stop. So we need to find the speed. Well, where do we go? Where do we start? So we are told that they are 800 meters. They are 800 kilometers. So what we've done in our previous example, we know what that 800 kilometers means. It means that our area is indeed 800 meters apart. I'd like for you to watch my other two previous examples in order to catch up on how did we get the area to be 800 meters. So if it is like that, what else do we know? We know that there is a duration of 9 seconds, so it maintains a speed of 9 seconds. So V is equal to 9 seconds. And when V is equal to 9 seconds, it stays there. It stays constant. I don't know which V should I call this. Maybe V or yeah, let me just leave it at V. And we know that the total duration, total time is equal to 2 minutes, which is equal to 120 seconds, in fact. So with all that information, let me, okay, that's a terrible line. Let me try to draw us a graph. Okay, it's gonna go like this. This is our vertical axis, which is the speed. This is gonna be the speed in what? In meters per second. And this, uh, my hand is failing me at the most important of times. Okay, so this is gonna be the time in seconds. Let me also put some brackets there, and that is 0.0. So it accelerates uniformly to a maximum speed. We don't know the speed. We don't know it. We're not told. So let that speed be our V. And what else do we know it V? We know at V, it lasts for 90 seconds. So that duration lasts for 9 seconds. So after 9 seconds, it's going to be like that. Now after that 9 seconds, it's going to decelerate again uniformly. It doesn't actually matter. I'm just going to leave the gradient like that because we are not told much about the gradient. So I'm just going to leave it as like that. Remember, okay, let me just exaggerate it a bit. I don't want it to be and we are told that the duration lasts 120 of them seconds. And what else do we know? We know that the area of this shape is equal to 800 meters. Okay, now what is this shape? What is this shape? This, guys, is actually a trapezoid. And we know from our previous examples that the area, or from basic mathematics, of the trapezoid is equal to half of the parallel sides. In this case, okay, I forgot to say this is 90. That's actually 90. The duration between there and there is 9 seconds. It's actually that 120 of that 90, which are the two parallel sides, multiply the distance between those two, which is this v that we are looking for, is equal to 800, meaning that v is equal to this 800 divided by what, if you 120 plus 90 minus 0.5, that is, I think that is 105, which is equal to 7 point, where's my calculator, 619, yeah, yeah, 7.619, let me leave it at that. Therefore, V max, or just simply V, is equal to 7.6 meters per second. We've solved that problem. So guys, that's the end of this chapter. Hope you enjoyed it, and please like, subscribe, and comment. That will make my heart feel so welcome by you guys. That will motivate me so much. You don't know how much it will mean to me. Um, Thank you.